Today we're going to be talking about our Cessna 150. It uses a 4-cylinder horizontally opposed Continental O200A. Its operation is based on the 4-stroke combustion cycle. This engine converts fuel and air into the mechanical power to turn the propeller. It is a carbureted, naturally aspirated engine, meaning it uses atmospheric pressure to bring air into the cylinders. The engine is air-cooled using airflow and cooling fins to remove. Alright, this is a 4-stroke cycle. Each cylinder completes 4 strokes. First stroke is an intake stroke. The intake valve opens, piston moves downward, fuel and air mixture enters the cylinder. Second stroke is compression. Both valves close, piston moves upward, fuel and air mixture is compressed. The third stroke is power. Spark plug ignites in the compressed mixture. Expanding gases forces the piston downward. This produces usable power to rotate the crankshaft and the propeller. And the fourth and final stroke is an exhaust stroke. Exhaust valves open, piston moves upward, burned gases exit the cylinder.
Today we're going to go over the power plant and the prop combination for the Cessna 150. Over here we have the McCauley OCM 6984. The 6984 is for the dimensions of the blade itself. So it's going to be 69 inches in length and 48 inches in pitch. Right here, this is a fixed pitch propeller. So no matter at what speed, whether it be takeoff, landing, cruise, the pitch of the propeller does not change at all. It'll only change in relations with the RPMs of the engine itself. Speaking of that, the power plant system for this is going to be the Continental O200A. 200 meaning this is a 200-inch. For the power plant of the Cessna 150 is going to be the Continental O-TEC 200 TEC A engine. O meaning horizontally opposed, meaning all of these pistons right here are moving in opposite directions horizontally from each other. And 200 meaning that it is 200 inches of displacement when operating on one full cycle. For the induction system, the Continental O200 operates with a carburetor with a flow type system with an updraft, meaning air is pulled into the carburetor, mixes with the fuel, and flows upward into the cylinder. Once the air-fuel mixture comes into the engine, right here to each of these cylinders, is beginning of the 4-stroke process. So the first stroke is going to be the induction stroke, which is going to be pulling the air-fuel mixture into the cylinder itself. So when it pulls it in, comes from the carburetor up here, into the cylinder. Next out on the 4-stroke process is going to be your compression stage. So what's that going to be doing is going to be compressing the air-fuel mixture inside of each of these cylinders. And once it gets to the very top, we call that top dead center, it's going to ignite using the magnetos. And speaking to the magnetos, each cylinder has 2 spark plugs. One at the top, one at the bottom. Same for each cylinder on every side. With this engine, it has a dual magneto system, meaning it is built for redundancy. As this engine operates, each magneto has 1 spark plug attached to it to each cylinder. And on each side, 1 magneto will control 2 of the spark plugs on the top side of the left side, and the other side will be controlled by the bottom by the same magneto. Therefore, if one of these magnetos goes out, you'll still have another spark plug to be able to operate this engine. And also, that lets it work independently of the electrical system. So as you can look here, there's no battery on it. If this engine were to fail through the electrical system, this engine will still be able to operate. Last thing we're going to talk about is the last 2 strokes of the 4-stroke system, and that's going to be your power stroke. So once after the compression stroke, the magneto sends a spark to the spark plug to ignite the air-fuel mixture, and after that, as it rotates, that's going to be your power stroke that actually drives power from the piston to the crankshaft to the propeller. And once that's done, it'll move again for the exhaust stroke. What's going to happen is that after the power stroke, it's going to push the rest of the exhaust gas out of the system, so therefore it could begin the cycle again. And each side is going to be 2 cylinders connected to 1 exhaust manifold, as you can see here and here. Finally, this propeller and engine combo is based on this fixed pitch propeller design, meaning that the only way this propeller will turn at a faster RPM is if the engine runs faster as well. So as the engine runs at a higher RPM, the propeller will run at a higher RPM as well. They do not turn in pitch, it's not constant speed or anything like that. Now, the normal operating range is going to be at 100 horsepower, and that means the engine is going to be operating at an RPM of 2,750 rotations per minute.